Okay, in this video, we're reviewing our balancing problems 4 to 10. Now, we've already done 1, 2, and 3 in class, so now we're going to balance 4 through 10 in this video. So check your answers as we're going through. We're going to continue going through the 5-step process as we balance for it. So number 4, remember we're going to find our arrow and draw our line down, and then create the identical list on both sides. So we have CL equals, K equals, and BR. Before I even start looking at how many there are, I need to write the same exact list. So you might even want to have scrap paper out as you're doing this, whether it's a review during our pair deck, you can actually write on it, or on the quiz. So we're going to see CL has 2, K has 1, and BR has 1 there. Then our CL is going to have 1 on our product side, K is 1, and BR is equal to 2. So now is where we're going to start to go through and balance for what we have. So we have 2 CLs on our reactant, and we have 1 CL on our product. So we find CL, and we're going to put a 2 there. It not only changes the desired CL to 2, but it also changes the K to 2 also. So now our CLs are balanced, but now our potassiums are not. So go back to the opposite side, and we see we have a 1, and we're trying to make it look like a 2. Remember, coefficients are multipliers, so 1 times what gives us 2? 2. Perfect. It not only changes our desired K, but it also changes BR too. So look at that. We are all balanced. We have 6 on our reactant side, and we have 6 on our product side. Hooray. Now, if you're like me and you can't leave a line blank, you could write 1 and 1 right there. Okay, number 5. We're doing the same exact process we just did. Find your yields, draw your line down, and create the same identical list on both sides. So we have Fe, we have O. We have Fe, and we have O. So how many Fe's do we have? If there's no number there, that's 1. O is going to be 2. Fe is going to be 2, and O is going to be 3. So now let's start balancing. How do I make a 1 look like a 2? I'm going to place a 2 there. So I placed my 2 there, and I'm balanced for now. So you might have already tried this one and saw that it might not work as perfectly as you'd like. Because if we look at our O's here, we see we have a 2, 3 situation. So we need a common multiple between 2 and 3, which is 6. So 2 times what gives us 6? 3. So we place our 3 up here, and it changes our O to 6. So then what do I need to place on this one to make it a 6? A 2. So when I do that 2, it not only changes my O to 6, but it changes my Fe now to 4. So are my Fe's balanced? No. So in balancing, it's okay if you have to erase and work through it again. So we're going to actually need a 4 here. So 1 times 4 would give us 4. So now we have 10 on this side and 10 on that side. So we would see that it's a 4, 3, 2 balance for this. It was a little trickier for this one because we had to go back and change something that we had already done. So if you're working on a scrap piece of paper, you might want to use pencil for these problems. Okay, number 6, find your arrow, draw a line down. AL is equal to how many? CL is equal to how many? Then write the same exact list on both sides. AL is 1, CL is 2, AL is 1, CL is 3. So yet again, we have a 2, 3 situation. So we're going to need a multiple of 6. So we need our 3 here, which changes it to 6. And we need to put a 2 here. It not only changes my CL to 6, but it changes my AL also. So now I have a 6, 6. Perfect. But I have 1 AL on my reactant side, and I need 2. So I'm going to put a 2 here and then change it in my chart. And we are all balanced with 8 on both sides. So this would be a 2, 3, 2. Okay, our next one we have for number 7. We're going to draw our line going down. We have SN, we have O, we have H. We have SN, we have O, and we have H. And so now let's write how many we have. SN would be 1, O would be 2, H would be 2. On the product side, it would be 1, O would be 1, and H would be 2. So now we need to balance. It looks like our SNs are already balanced, so we go to our O. We have 2 on this side and 1 on this side. So what can we multiply 1 by to give us 2? It is 2. So we find our O, we put our 2, and it not only changes our O to 2, but it changes our H to 4. So we go back to our reactant side of H. How can we make a 2 look like a 4? We're going to have to add a 2. So 2 times 2 is 4. We have 1 and 1, 2 and 2, and 4. And then that means we can put 1s in these spots for it. So we have a 1, 2, 1, 2 for this balancing. Okay, number 8, we're almost there. Find your arrow, draw a line going down. We have our AL, we have our FE, and we have our O. We're going to write the same exact list as we're going across. So we're going to see we have 1 AL, 2 FEs, and 3 Os there. We're going to have 2 ALs, 1 FE, and 3 Os there. So let's start with our AL first. So we have 1 here and 2 here. So what's a multiple for 1 and 2? We're going to times it by 2. So 2 times 1 is 2. We are balanced there. We have a 2 on our reactant side for FE and 1 on our product side. So we're going to put a 2 there. And now we have 2. We're balanced. And then our O's were balanced all along. We can put 1s here as placeholders. So we would see this is a 2, 1, 2, 1 for it. Number 9 is the first one that we're going to have to add up like terms. So let's draw our line going down. We have K, we have O, we have H, and we have another O. So if they have the same chemical symbol, we're going to add them up like we would in math for like terms. And then we're going to have a K, O, and H. So we have 2 Ks, then we have 1 plus 1 gives us 2 Os, and then H would be 2. On the product side, we have 1, 1, and 1. So let's start at the top for it. So we have a 2 on this side and a 1 on this side. So how do we make a 1 look like a 2? We're going to place a 2 there. It not only changes the desired potassium, but it also changes our O and our H2, which actually makes it all balanced for 6 on both sides. So we can add 1 here and 1 here. Okay, our final one is a doozy. It's a combustion reaction, and we'll notice that we have to add up like terms again on the product side. So we have our C, we have our H, and we have our O. We have our C, we have our H, and we have our O. So C is 2, H is 2, O is 2. C is 1, H is 2, and then O is 2 plus 1 gives us 3. Now, when I'm doing a combustion and I notice that I have an odd 3 and I have an even O, I can't just use the rule for 6. So I actually want to make this O on the product side even. So automatically what I do first is put a 2 there to make that even, or to make that odd O even. So that changes my H to 4, and then I have a 2 here. 2 plus 2 gives me 4. I can work with 4 with my oxygen. So now go back to the other side. I have 2 H's here, and I have 4 on this side. So how do I make a 2 look like a 4? I'm going to put a 2 there. So now 2 times 2 would give me 4 C's, and then it would give me 4 H's. So I'm balanced there. So now I have 4 C's on my reactant and 1 on my product. So I'm going to need to put a 4 there. So I have now 4 there. And then I distribute it to my O. So I have my O2. 4 times 2 is 8. 8 plus the 2 that we already had gives us 10. So what number times 2 gives us 10? That would give us 5. And combustions are the trickiest ones to go through. Now, you might not see that on your quick quiz coming up, but it's always available for our future tests. Thanks for watching.